Welcome to my YouTube channel. Feel free to like, comment and subscribe. Today we are going to learn about binary arithmetic operations. Binary arithmetic operations. This is how we can add, we can subtract, multiply and also divide binary numbers. This is how we can add, subtract, multiply and also divide binary numbers. So as from Form 1, we know that central processing unit, or the CPU, is divided into three parts. That is the control unit, the arithmetic logic unit, and also the main memory. The mathematical operations and comparisons are carried out in arithmetic and logic unit. So there is a way in which computers add, subtract, multiply and also divide binary numbers. It is not the same way we are used to decimals, adding decimals, subtracting decimals, dividing decimals and multiplying decimals. In binary, it is not that way. We are going to learn how it is done just some few minutes. So it is just introduction, and you should know that arithmetic and logic unit performs all those calculations. For the subtraction, it is not done directly. It is done by something we call complementation, the one which we are going to learn that very soon. Complementation. The division and multiplication is done by something we call shifting before adding the bits method. Shifting before adding the bit method. But the last one, which is addition, can just be done directly by the CPU. Even in your calculation, when we will start calculating, you will see that addition can be done directly. So let us go. That was just introduction. Let us, before we go on the mathematical part, let us see how to represent binary numbers. That is the representation of signed binary numbers. Representation of signed binary numbers. In the previous tutorial, we saw that we just wrote binary numbers without signs, without knowing that if this binary number we have written, if it is positive or negative. But there is a way we can represent binary numbers in such a way that we know whether that binary number is positive or negative. We know we can differentiate it from negative, and the positive can be differentiated. How can we differentiate them? In this subtopic of representation of signed binary numbers, we are going to learn how to differentiate them and how to represent them, whether the binary number is negative or positive. I'm sure if I write a binary number, you don't know if it is positive or negative. But before the end of this subtopic, you will have knowledge how to differentiate the positive binary number and negative binary number. The positive binary number and negative binary number. How do we represent signed binary numbers? One, we have the first method, which is called prefixing an extra sign bit. Prefixing an extra sign bit to the binary number. Prefixing an extra sign bit to the binary number. 2, using 1's complement, and 3, using 2's complement. Using 1's complement, using 2's complement, and prefixing an extra sign bit to the binary number. Let us start with the first one, which is prefixing an extra sign. Prefixing an extra sign bit to the binary number. Prefixing an extra bit to the binary number. So in binary numbers, we have done this in binary numbers. whereby you represented numbers like, let us take an example which I have given you here. You represented numbers back in, just let's say in lower classes, you represented numbers and you say the number can be positive or negative. How do you indicate that a number is positive or negative? It is done by just prefixing it with either positive sign or a negative sign. That is in decimals, because we have learned decimals since lower classes. You know that to represent a decimal number, you just add a positive sign or a negative sign before the number to show that the number is either positive or negative. For example, or for instance, is this 27 under base 10, showing that this is a decimal number, and we have a negative 27 showing that this is a negative number. This is a negative number. So that is how we did back in lower classes to represent decimals, to show that they are either negative or positive. It can be done the same way with the binary numbers, but in binary numbers you cannot put negative or a positive sign. You cannot put negative or a positive sign. What we do to indicate that the number is either positive or negative is just adding an extra bit. Adding extra bit. You know that bits in binary numbers is just 0 and 1. Those are the bits we are talking about, 0 and 1. If you talk about bit, you talk about 0 or 1. 0 or 1. So you add an extra bit. You add an extra bit to that binary number you want to indicate whether it is positive or negative. For instance, let us take an example of a decimal number, which is 127. If it has no sign at all, it means that it is positive. That is what we learned in lower classes. We write, because it is commonly used number system. If we just write 127, it is base 10, and we don't indicate whether it is positive or negative. It means that that number is positive. That is well known. So convert the 127. What do you do to indicate that a binary number is either positive or negative? If you are given it as a decimal number, like in my case here, you have to convert that number into a binary number. You have to convert it into a binary number. And in this case, my binary number is 11. In fact, I have 7 ones. I have 7 ones. If you can count them, that is when you convert 127 to a binary number. You'll get 7 ones, base 2, showing that this is a binary number. It is under base 2, showing that it is a binary number. How do we now show that this binary number is either positive or negative? We add 0. We prefix it with 0 to show that it is positive, like this. So my 127, which is positive, is that one. My 127, which is positive, is that one. I have prefixed it, or I have to indicate it, I just prefix it by 0. Before the number, I put the 0, like the way it is shown there. That is to show that the number is positive. The binary number is positive. That is one way of representing signed binary numbers, to show that they are positive or negative. The other one, to show that the binary number is negative, you just add an extra bit, which is 1, like the way I have shown you there. That is, if you add 1, it means that the number is negative. The number is negative. But we have a problem of using this system of prefixing. We have a problem when we are using this system of prefixing a binary number with either 1 or 0, because can you tell me how do we write negative 0 or positive 0 in decimal numbers? In that question, you'll just tell me a 0 is just a 0, a 0 is just a 0, a 0 is not negative or positive. So we have the same problem when it comes in prefixing zeros and ones to indicate that a binary number is either positive or negative, because if I put a 0 before zeros of a binary number, it will remain to be a 0. If I put 1 before zeros, it will still remain to be a 0. So we have that problem when it comes on representing a 0 in binary number, we have two ways in which we can represent the 0, by either putting 0 or putting 1, because it means the same. We don't have negative or positive 0. We don't have negative or positive 0. Let us go to the other one, which is the ones complement. The ones complement. It is another way of representing signed binary numbers. So, what is a complement? Let me take you back to mathematics. Studies. If you have an angle of 180, that is an angle of a straight line. Angle of 180, that is an angle of a straight line. And let us divide that angle into two. Not exactly equal parts, but just two. Let us say one angle is 60, the other one is 120, to make the whole angle in a straight line, which is 180. We can say that angle 60 complements angle 120. Angle 60 complements angle 120, so that 60 and 120 can make up the whole angle in a straight line, which is angle of 180. The same way, we can apply the same way here. We can use the complement method, whereby you write a number. This is mostly, it applies when we are subtracting. The binary numbers. It applies when we are trying to subtract binary numbers. So that idea, we can also apply it in binary numbers. And the idea of complement is used to address the problem of signed numbers, which is positive or negative. You will come to learn that when we will be doing subtraction and addition, more so subtraction using complement method, we solve the problem of having a negative binary number. When we are subtracting them, it is like we will be adding them. So that one will solve the problem of having either positive or negative. In fact, we will take them, all of them, like they are being positive binary numbers. But what we are doing, you know that if you are subtracting 2 minus 1, the minus 1 is negative. But in this one, we will be adding, like we are saying 2 plus minus 1. It is like you are adding minus 1 to 2. But that one will give you an answer like you are subtracting. So let us take also numbers, decimal numbers 0 to 9. 0 to 9. We are talking about 9's complement. If we take 0 to 9 numbers, which are decimal numbers, this one we talk about 9's complement. For example, if we want to make up 9, like the example above there, which is example of an angle, if you want to make up 9, we can have the following complement numbers, that is 5 and 4. 5 plus 4 will give you 9. 3 and 6, it will give you 9. 7 and 2 will give you 9. 3 and 6 will give you 9, and so on. 1 and 8, all of those will give you 8. So we can say 1 complements 8, or 8 complements 1, to make up a 9's complement, to make up the 9's complement. So however, in binary numbers, the 1's complement is the bitwise not. The bitwise not applied to the number. However, in binary numbers, the 1's complement is the bitwise not applied to the number. So what does that mean? It will not be the same complement we have seen, like for that angle in the above example, or for the 9's complement where we have 5 and 4, or we have 3 and 6. It will not be the same. We will do something we call, it is a complement, but in this case in binary numbers is called bitwise not complement. It is known as bitwise not complement. How is it used? When you are complementing a binary number, for example, let us say the bitwise not of a binary number, this one. Let us be together. The bitwise not, we are saying this is a complement of a binary number, but it is not done the same way we have done that one for the angles, or that one for the 9's complement. For the 9's complement. So let us go back to what we are doing. So if, for example, we want a bitwise not that is a complement of this binary number using this system of bitwise not, which is not the same as 9's complement, but it is a complement of that number. What we do, this is my binary number. This is my binary number. In fact, this is just a mistake. This should be a subscript 2 because it should be 100 subscript 2. It should be 100 subscript 2. So just ignore the 2 because this is a binary number, and the 2 is a subscript which shows that is a binary number, or it is under base 2. Bitwise not, which is a complement of this binary number, will be this one. So what have you learned from that? What have you learned from that? You will learn that whatever was ones becomes zeros, and whatever was zeros, it becomes ones. Have you seen that? Whatever was ones becomes zeros, and whatever was zeros becomes ones. That is known as bitwise not complement of binary numbers. Bitwise not complement of binary numbers. You have seen that it is not done the same way like the way we have done the above example, although they are all of them are complements, but it is not done the same way. In this one, whatever was zeros becomes ones, and whatever was ones becomes zeros. So we can say this number, or this binary number, is a complement of this one, or this binary number is a complement of this number. What we do is just negating. The system known as negating. To complement binary numbers, you do something known as bitwise not, which is negating ones and zeros, whereby zeros becomes ones and ones becomes zeros. So if someone tells you, can you write the complement of this binary number? Wherever we add ones, you'll write zeros, and wherever you add zeros, you'll write ones, and you will be okay, or will be okay to go. You will just negate zeros to ones and ones to zeros. Likewise, the bitwise not of this kind of a number, which is number 45, which is a number 45. This is a number 45, a binary representation of a number 45. It will be this one. What have you noticed? Whatever we add zeros in the positive 45, positive 45 was starting with 2 zeros, and negative 45 is starting with 1. The second part, or the other bit, which is 1 0, will be 0 1. The other one, which was 1 1, will be 0 0. And the last one, which is 0 1, will be 1 0. You'll find that we have not done negation. We have done negation. We add 45, and the complement of that number in binary form will be negative 45, which is this is 45, this is 45, and this is negative 45. Hence, we have represented the binary number by writing the positive part and the negative part. We have written the positive part of 45 and the negative part of 45 by doing what we are calling complementing, using the method of bitwise not. Using the method of bitwise not. This is applied in binary numbers, bitwise not, where you negate ones and zeros. Wherever we add zeros, it becomes ones, and wherever you add ones, it becomes zeros. It still bears the same problem of representing a zero. Representing a zero, because zero, when you want to represent zero, it will have the same problem, because it can be represented in two ways. It can be represented in two ways. In this one's complement, you can represent zero in two ways. So that also remains to be a problem. Let us see the 2's complement if it is going to solve the sign of zero, representing a zero using two methods, which is either you put it 0 or 1. Will the 2's complement solve that? Will it solve that? Let us see. What is the 2's complement? What is the 2's complement? 2's complement is very similar to 1's complement. 2's complement is very similar to the 2's complement. How do you do it? Before even we go on how we do it, we can see that we have advantages of using 2's complements over 1's complement. What are these? The advantages of using this method in representing signed binary numbers. There is no two ways of representing zero. In 2's complement, we don't have two ways of representing zero, like the above prefixing, the 1's complement, all of them add that problem. We have two ways of representing a zero, binary number zero. It is represented in two ways. So this one caters for that. The 2's complement will cater for that. It will just have one representation of zero, not two. Not two. We have effective addition and subtraction can be done even with the numbers that are represented with the sign bit without need of extra circuitries to examine the sign of the operand. What do I mean? I mean that you don't need to examine. When you are adding or subtracting, you don't need to examine. Examine now. You don't need to determine whether this is a positive binary number or if it is a negative positive number. You just go on and carry out the operation of addition and subtraction. Are you together? But above there, you have to make sure you know the sign of the number you are dealing with when it comes to subtraction and addition. You know that when you write a binary number, as we wrote in previous tutorials, you saw that we never indicated whether that number was negative or positive. When you are using 2's complement, you'll just do addition and subtraction. You don't need to examine whether it is positive or negative. But when you are using prefixing method or 1's complement and you use those numbers to add or subtract, you have to examine whether that binary number which is there is either positive or negative. I think we are together. How do we write numbers, or how do we represent signed binary number in 2's complement? That is, you just do the same. You have to convert, for example, you have to convert your number, because mostly you can be given a number which is a decimal, or like my example here, the number is 45. I have to convert my 45 to 1's complement. I have to convert, in fact, what I'm saying is that I have to convert my 45 into binary number, which is my 45 in terms of binary number is this. But here, notice that I'm using 80 bits. Notice that I'm using 8 bits. I'm using 8 bits. So after I convert, so if you don't have extra numbers, you just add zeros before your binary number to make up 8 bits. To make up 8 bits. So we have converted our absolute 45 to a binary number, which is this. In fact, it's a positive 45. Absolute of it, 45, which is decimal, into a binary number, which is this one. After you convert it like that, you write it bitwise not. You write it bitwise not this way. You write it bitwise not, and a bitwise not of that 00, 10, 11, 01. The bitwise not of that, which is a complement of that number, will be 11, 01, 11, 10, 0, 1, 0. In fact, you know this one from the ones complement. We have up to that point we are doing ones complement. So the twos complement of the bitwise not of 45. The bitwise not of 45 is this one, which is binary number of 45 being negative. In fact, this is a negative 45 in binary numbers. It is a negative 45 because this one is positive, this one is negative. That is what we call bitwise not from the above. If you want to write this one bitwise not, you want to write it in twos complement. What do? You just add one extra bit. You just add one extra bit. Like for example, here you add 0. Look at that one. You add 0. But to make up the twos complement, you just add 1. Simple. You just add what? 1. After your all conversions, you just add 1 at the end of the number. So we add 0 plus 1, it became that number now, which you can see there. We have meant we converted 45. Let us revisit again. We converted 45 to its binary equivalent. Then after that, the binary equivalent of 45, we had to take its bitwise not binary number, which is this one. If you take, after you take the bitwise not of the binary number of 45, you write in twos complement, which is 11, 0, 1, 0, 0, and then you add 1, which becomes 1, 1 at the end. You can try others. You can try a number like 23. You can try a number like 127. Write its binary equivalent and also write its bitwise not, and then after you write its bitwise not, write the twos complement of that bitwise not of that number. Okay. Up to that point, I'm guessing we are together. Let us go now to what we started and what you are anxious of. That is what you want to know. That is binary addition and binary subtraction. How is it done? How is it done? Binary addition. The basic rules of binary addition. The basic rules of binary addition. So, binary addition, that is where we are. There are 5 rules or possibilities of adding binary. There are 5 possible addition in binary or possibilities. When you are adding binary numbers, you know you can add something which cannot be added to another one. So we are exploring the possibilities of adding, or the binary numbers which can be added to one another. Let us start with 1. A binary number 0 and another 0. So 0 plus 0, which is a binary number, it will give you 0. Also in decimal places. Not decimal places, but in decimal numbers, it is the same. In decimal numbers, it is the same. 0 plus 1, it will give you a 1. I want to note this very well because we are going to use it. 0, which is a binary, plus 1, which is also under base 2, it is a binary. It gives you 1. 1 plus 0, it gives you another 1. Because it is the same as this. If you look at this, it is just the same as this, only that there is inversion. Where we add 0, there is 1, and where we add 1, we add 0. It is like 1 plus 2 and 2 plus 1. It will give you the same answer. Possibility number 4. If you add 1, which is binary, and another 1, which is a binary, it should give you 1 0. Note that 1 binary plus another 1, which is a binary, it gives you 1 0, which is read as 0 carry 1. It is read as 0 carry 1. The fifth possibility of addition of binary numbers is 1. Don't worry about these two. These two should be a subscript. It should be a subscript like this one. It should be a subscript. It's just a typing error. It should be a subscript like this one. Consider 1 and another 1 you add to another 1. Meaning this is a binary number, 1 plus 1 plus 1. 1 plus 1 plus 1. It should give you 1 1. I said these two is just, it should be a subscript like this one. It should be a subscript like this one. So it is 1 1 base 2. It is 1 1 base 2. I mean, I'm saying that 1 plus 1 plus 1. But in binary form, it should give you 1 1. Read as 1 carry 1. Read as 1 carry 1. The other one is binary subtraction. Binary subtraction. Binary subtraction. The other one is binary subtraction. What are the possibilities of subtracting binary numbers? Possibilities. What are some of the possibilities? Because there is a way you can subtract binary numbers. You find that it is not possible to subtract them. Possibilities when you are subtracting binary numbers. What do you do? 0 minus 0. Also in decimals, you know that 0 minus 0 is always 0. That is something you know. 0 minus 0 is 0. 1 minus 0 is 1. Also from binary number. From decimal numbers, you know that. 1 minus 0, it will give you 1. Or any number minus 0, it will give you that number. Exactly. That is something we know. What you may not know, also this one you know. 1 minus 1, it means this is a number which is equal to this one. And if you subtract a number from another number which they are equal, obvious, you will get a 0. Obvious, you will get a 0. For example, 10 minus 10, it is a 0. 2 minus 2, it is a 0. 3 minus 3, 100 minus 100 is a 0. The fourth possibility is 1 0 minus 1. 1 0 minus 1. You remember that one? We done it above there. We have done it above there where we were adding 1 plus 1. It gave us 1 0. So it is now we are subtracting 1 0 minus 1. 1 0 minus 1. Obvious, the answer will be 1. The answer will be 1. This is the case here. 1 0 minus 1. the answer should be 1. The answer should be 1. Read like the way you can see it here. So now you understand the basic rules of adding and subtracting binary numbers. Let us go now, in around 5 or so minutes, let us go and do binary additions. Binary additions, as I introduced above there, I said that it can be done directly. It can be done directly, not like subtraction, which you have to use 1's complements or 2's complements. Addition, you can do addition just directly. Let us go and see how you can do that. Binary additions, and I have 3 examples. Binary additions, and I have 3 examples. Let us see how we can add them. Welcome. Binary additions. What do you do when you are adding binary? When you are adding binary, you add them directly. Let us see. This is 1 plus 0. 1 plus 0. 1. This you have to add. We are adding this binary number which is above there to this one. This binary number which is above here to this one. And you will notice that this binary number which is above here is equivalent to decimal number 13. You will also notice that this binary number which is below here, it is equivalent to decimal number 14. Confirm? Hope that you have confirmed. Let us go on and add 1 plus 0. From above there, 1 plus 0, it gave us 1. 1 plus 0 was giving us 1. I told you it's very simple to add binary numbers. 0 plus 1, it was giving us 1. Sure. 1 plus 1, it was giving us 0, and then you carry 1. It was giving us 0, then you carry 1. So in this column here, I want you to be very careful now. In this column here, we have the carried 1 plus 1 plus 1. How many ones do we have? 3. We have the carried 1 because 1 plus 1 is 1, 0. So you write the 0 and carry 1. The carried 1 is added to this column here, whereby we will have 1 plus 1 plus 1. And from the above addition there, the rules of adding binary numbers. 1 plus 1 plus 1 should give us 1. Carry 1. They should give us 1, carry 1. We carry that 1 here. Now this is the one which is carried. The carried 1. That is the one which is carried. That is, I have put some color there. I have highlighted it for you to see. The highlighted one is the carried 1 from here. Because it was 1 plus 1 plus 1, which is 1, 1. We write 1 and carry 1. This is the carried 1. 1, the carried 1, plus nothing. We have nothing there. The carried 1 plus nothing, it will give you 1. That is the binary equivalent of that. Or not binary equivalent, but that is addition. When you add that number to the other number, you can confirm it by adding 13 plus 14 and then also converting this one to binary number. Let us convert together. You can convert and see that this will be 1. This should be 1. 1 plus 2, 3. 3 plus 8. 3 plus 8 is supposed to be 11. 11 plus 16. 11 plus 16, it is supposed to give you 27. It is supposed to give you 27. Correct? 13 plus 14 is 27. So we have confirmed that our addition is right. We have confirmed that our addition is right. You can do the same. You can confirm wherever you do your addition, subtractions, you can convert them to their decimal equivalent and then add or subtract and see if your answer is correct. For that one, now we have confirmed that it is correct. You can go on and do the same to the others, the same way we have done there. This will be 1, 1, 0. This will be 1 plus 1, which is 0, and then we carry out 1 there. We carry out 1 there. Do the same to this one, which is 1. 1 plus 1 is 0, carry 1. It should be 0, carry 1. Then we have carried 1 from here. 1 plus 1 again should be 0, carry 1. 1 plus 1 again, it should be another 0. It should be another 0, carry 1. You carried 1 here. 1 plus 1 again should be 0, carry 1. It should be 0, sorry, it should be 0 here, carry 1. The 1 is brought here. 1 plus 0 plus 0, it should give you a 1. And then 1 plus 1 is 0, carry out 1, which will be an extra bit in that addition. You can go on and convert this one to binary, to decimal equivalent, write it here. Convert this one to binary, to decimal equivalent, write it here, and then add them and see if you will get the same decimal equivalent of the answer. Let us do the same very quickly to that one. 0 plus 1 is 1. 1 plus 1 is 0, carry 1. Is 0, carry 1. 1 plus 1 is another 0, carry 1. 1 plus 0 plus 1 is another 0, carry 1. 1 plus 1 plus 1, this is 1, carry 1. That is 1, carry 1. 1 plus 1 plus 1 is another 1, carry 1. 1 plus nothing, which we have carried here. We have a carried 1. We have a carried 1 there, which I can highlight it. The highlighted one shows that that is carried 1. Also here we had a carried 1. We can highlight them for you to differentiate the ones which were there and the carried ones. The final overflowing bit. The final overflowing bit. This is a carried 1, which will give you 1. Which will give you 1. I hope up to that point you know how to represent binary numbers using signs. You can tell whether a binary number is positive or it is negative. Up to that point now, you should be able to tell if a binary number is positive or negative. You can use either the prefixing 1 or 0. You can use the 1's complement, or you can use the 2's complement. We have also learned about basic possibilities on how to add and subtract binary numbers. We have learned how to add binary numbers. So let me end this lesson at that point, and welcome to the fourth tutorial, whereby we will be doing now the trickiest part, which is using 2's complement and using 1's complement in in subtraction of binary numbers. Using 1's and 2's complement in subtraction of binary numbers. Feel free, subscribe, comment and like. Subscribe, comment and like to my channel. Thank you for watching. God bless you.